All right. Make sure that on your formative assessment that you've got the right radius here. I do believe I printed it with the wrong radius. I'm so sorry about that. Okay, so this is just a regular vertical circle one. And 2 and 3, I'm going to tell you this. You'll always be able to find the centripetal acceleration and you'll be able to find the weight. That'll be our first steps here, right? So in this case, we've got the period, right? So the centripetal acceleration is 4 pi squared r over t squared. And then some of them I'm going to give you the velocity, right? So it'll be v squared over r, but that's what this one is, right? So let's figure this out. 4 pi squared times 0.31, right? We got to do this first, and then we can figure out clever things like what's the force at the top. Okay, so let's see, we got to square that. So now we just need a calculator. Here's one. All right, here we go. This is 4 times pi. Oh, you got to turn your calculator on first. 4 times pi squared. It's the end of a long day here. Times 0.31 divided by 1.3 squared. And that's 7.2416. All right, meters per second squared. So notice that that is less than a gravity, right? And so that means that even at the top of the circle, we'll be actually exerting an upward force to keep the thing from accelerating down 9.81, right? You'll see. You don't need to understand that, but this is one of those things where the water is going to come out of the cup. The string won't stay taut. And that's why, of course, it's a rod. Okay, weight is just mg, right? So that's 2.5 kilograms times 9.81 newtons per kilogram. So that is, let's see, storage in A. And then I'm going to go, this guy, 2.5 times 9.81. I'm going to store that in W for weight. That's 24.525. Now, if you look at this thing when you're in a circle, okay, when you are at the top, okay, remember that the centripetal acceleration is always toward the center. When you're at the top, the centripetal acceleration is down. Okay, at the bottom, by the way, it will be upward, right? And that really is the only difference here. Okay, so as this thing goes in its little circle, okay, it's going to be at the top, I have a negative acceleration here. The centripetal acceleration in our frame of reference is positive, right? Okay, but here we're at the top, so we're doing this guy here, right? So we're going to go unknown force minus 24.525, and you only solved like 5 million of these. This is just a mass on a string problem with the added twist that we could be accelerating down possibly faster than gravity, right? So this force could be negative. But other than that, it's just like dancing. Okay, just like ballet. Okay, so here at the top, remember this centripetal acceleration is down. Why is it down? Because the center, it's always toward the center. When you're at the top, the center is below you, so it's negative 7.2416. Okay, now we can solve this, right? So I'm going to go 2.5 times negative that, right, plus this. And I'm getting F is positive 6.42 newtons, and that would be, of course, up. And you do need to say that. I need you to say up or down, because I think some people don't understand that the positive means that it's up, right? Now, if it comes out negative, you're going to be saying down, right? All right.